All right, guys, we're going to be starting in chapter 9. So this is dealing still with quadratic equations. Today we're going to talk about how to graph them, and might be a bit of a long notes. This is also, in this chapter, we're going to be covering a lot of different topics, but prior to the placement test, we're just going to cover two. The most important ones, and then we'll come back after you take the placement test June 3rd, and we will go back and visit other parts of the chapter. Okay, so let's get started. So let's reiterate, what is a quadratic function? So just a little hint, you will be doing some graphing. If you want to, I would suggest printing out graph paper if you don't have access to any. It really does make graphing a lot simpler. So a quadratic function has a degree of 2. Now remember, degree is you take each monomial that's part of the equation and you count up all of the exponents on all of the variables on each monomial. So if you had a squared b as part of a monomial, then you would have a 2 from the a and a 1 from the b, and that would make it a third degree. Wouldn't make it a quadratic, but it would make it a third degree. That was a question that was on the test that many people missed, the first one, chapter 8. Okay, so it has a degree of 2, so that's the max you can have. I got myself some mess over here. Okay, has a degree of 2 and has a non-linear graph. Okay, and when it's written in standard form, and we've seen this standard form before, it looks like this. F at x is equal to ax squared plus bx plus c. Now, one stipulation is that the coefficient, the quadratic coefficient, cannot equal 0. You need that quadratic term. If you don't have that quadratic term, then it's not a quadratic function. Okay, so let's just jump right over to, what do we call this graph that's nonlinear? We call it a parabola, or parabola is what it looks like. So it is the graph of a quadratic function. It's symmetric about a line down the center of the parabola. Okay, and this guy has a name, very important name. He's called the axis of symmetry. Now, when we were doing a problem, there's one about an arch, and we're trying to figure out what the high point was. It was basically introducing this idea, okay? Now, let's talk a little bit more about that axis of symmetry. So, the axis of symmetry plays a very key role because the axis of symmetry intersects the parabola at its vertex. Okay. The vertex is going to be either the topmost point if your parabola is facing down, or bottommost point if your parabola is facing up. So let's draw a picture so you can see what I'm talking about when I'm mentioning vertex. Okay, so I'm going to do little axes, X, Y. I'm going to do two of them. Okay, and I'm just going to draw a parabola. Okay, and we're going to draw in that vertex. And we're going to draw that axis of symmetry that's passing through it. Oops, no, he's purple. Boom, 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 boom. So if I folded along that dashed line, the two halves of the parabola meet up exactly. Okay? So let's kind of add some pieces here. So this is your vertex. Okay? And this is your axis of symmetry, the purple guy. Okay. And what we notice is that the axis of symmetry is going to intersect at the vertex. Okay, so we have, I'm going to circle this up. We have this intersection point here. Okay. Now, because our vertex is at the bottom, he is called a minimum. Okay. And that's the lowest y value for your parabola. Okay. So these guys, the two red guys, are the intercepts. I should change that and add the word x. X-intercepts. We've talked about this before. This is why we do solving quadratic equations. Also known as roots, also known as solutions. Okay? So let's go over to the other side and let's do another parabola. And let's say he is that's what this one looks like. So here's the vertex for this one. And notice that the axis of symmetry happens to be the y-axis. And that's a definite possibility. Okay. And because I have the vertex is up at the top, it's called a maximum. Because it's the most. It's the highest point. So it has the highest y value. Okay. Now, again, we do have our x-intercepts, y, or x-intercepts, roots, solutions. Now, we can actually sometimes, I'll do one more picture. It is possible that when drawing our parabola, that our vertex is also a root, okay, and the only root. Then that's another possibility that we can have. So this guy plays two roles. He's the vertex, and he's also, I'm going to put a red ring around him, he's also the x-intercept. okay? And you would only have one, so that's another possibility. Okay, so I want to cram one more thing on this screen before going to the next, and I want to talk about that axis of symmetry. Because he's going to play a vital role as we learn how to graph parabolas. So the axis of symmetry has a formula, and that formula is x equals negative b over 2a. So you might say, why is there no y involved? Well, remember, look at what kind of line that axis of symmetry is. It's a vertical line. And it passes through the vertex. Okay, so that is something you have to commit to memory, that axis of symmetry. Okay, so here's the interesting thing. Not only is the axis of symmetry passing through the vertex, it actually can help me calculate the coordinates of the vertex. Pretty important. So let's do a little note right here that axis of symmetry is the x coordinate of the vertex. See all those relationships? It's all interrelated here, okay? And then, but if I want to find the coordinates, both of them for the vertex, which is our starting point for graphing, then I'm going to need to figure out the y coordinate. So how do I figure out the y coordinate? I'm going to abbreviate that to y-coord vertex. You're going to substitute the x value into the equation and solve for y. Okay, and that's so important. Now, in the original function I wrote was f of x. Remember, f of x and y are the same thing. So I'm going to put f of x here. Okay? So, the number one thing that I need to do when I want to graph is figure out the coordinates of the vertex. The coordinates of the vertex are going to lead me to the second part, which is I need 5 points in order to graph. But we're not going to pick willy-nilly any 5 points. We're going to pick smart 5 points. So to graph a parabola, you'll need 5 points. And don't be lazy about this one. This is super important, okay? You don't have a graphing calculator. Not now. You get to learn how to do this by hand. Down the line you can use Desmos or whatnot, but that doesn't count now. You have to learn how to do this by hand, okay? So we're going to use something called a T-chart. And a T-chart is simply something that looks like a big T. Boop, boop. Where we're going to have X's and we're going to have Y's. So I'm going to give you formulaically how to do this, and then we're going to go back and we're going to take care of this in practicality. Okay, so for the 5 points, we're going to have 1 here, 2, 3, 4, and 5. You want to put the coordinates for your vertex in the middle. So this is going to be your vertex. Okay? Because what we want to do is we want to choose x values that are this equal distance to the right, to the left of your vertex, and you'll see why in a minute, okay? You got to trust me on this one. This is totally awesome. So you can add 1 to your y value, or your x, I keep saying y value, I'm so sorry, x value. And equally distance would be if I took my x coordinate of my vertex and subtracted 1 from it. And then we're going to take our x coordinate of the vertex, and then we're going to add 2 to it. And to make it equally distant, you're going to subtract 2 from it. So what you're going to do is build your parabola by having a vertex and then 2 points that are going to be on a horizontal line from each other, and then another 2 points that are going to be on a horizontal line for each other, and that will give you a good way of putting your parabola together. Now, here's where you got to trust me. When you're doing this, you're going to get y values that actually match, only if you follow this strategy. So what does that mean? We're going to get a new y value when I add 1 and subtract 1. It's going to end up being the same number if you follow me along, okay? Now again, we're just getting into theoretical, so we'll get into practical and do it. And then the adding 2 and subtracting 2 from the vertex value will give me the same y value, and that's going to be guaranteeing that your points are going to be on a horizontal line in groups. So a little bit about some basics. Domain, remember, what are your x values? In reality, they are all real numbers, which means your parabola is going to grow forever, right and left. You're just going to look at a little snippet of it. It looks like it's just going to go straight up, but it never goes straight up. It's always moving outwards, okay? So all real, ooh, that was a bad all real numbers symbol. There we go. That's better. And then what is your range? So what kind of y values can you get? Well, your range is kind of dependent upon your vertex and its y value. So the y coordinate of the vertex is the starting point of the range, or for the range. Okay, so let me give you 2 scenarios. Let's say we have a parabola, and let's say that it's facing upwards. So this is, we're going to have a vertex that is a minimum. So notice that your y values go from that point up. Let's say that point is 2. So I'm just going to draw pink, and then that would be 2. So for us, our domain, or I'm sorry, range would be the y values such that y is greater than or equal to 2. Okay, so, and it's always a greater than or equal to. So anytime you have a minimum, it's going to be greater than or equal to for your range. Okay, if I have a parabola that's facing downward, terrible parabola. He's called a maximum. That means the y values are going down. Okay, so again, let's call this point 2. We would say that the range is all values of y such that y is less than or equal to 2. It's always or equal to because it's a solid point. Okay, so maximum is going to have a less than or equal to. Okay, so let's get into graphing. We're going to do a couple of examples of that. So I'm going to go on to the next screen. And the directions are going to say, we're going to have different directions. So use a table of values. To graph y equals 3x squared plus 6x minus 4, state, domain, and range. Okay, so first off, get in this habit. List A, B, C. So those are going to be your coefficients or constant, and that's how we're going to start the process. Second thing we're going to do is calculate the axis of symmetry. And we're going to use our formula. X equals negative b over 2a. So in this particular problem, x is going to be equal to the negative. So these pieces are always there. The negative in the denominator are 2. And we're going to put in our a values. So if you look, we have a is equal to 3, b is equal to 6, c is equal to negative 4. So make sure you get your signs. Now notice in the axis of symmetry, C doesn't play a role, and that's okay, but C is going to be important when we talk about our next set of notes. So we're going to put negative of the B value over 2 times the A value. And then we just solve it. And we get negative 6 over 6, and that gives us x equals negative 1. Okay, so guess what? You've just calculated the x-coordinate of your vertex. Okay, next we're going to determine the vertex. Okay, and we've done that half of it. So we're going to have y equals 3, and then we're going to have negative 1 squared. I'm going to lighten this up. And then we have plus 6 times negative 1 minus 4. And do the math. And we get 3 times 1 minus 6 minus 4. So we get 3 times 1 is 3, and then we have minus 10, and we get negative 7. Okay, so our vertex is going to be negative 1, negative 7. Now I'm going to create my table, my t-chart. And here's where you can see the magic happen. So I'm going to pick my x's and my y's. In the center, I'm going to put that negative 1, negative 7. Okay, so 1 higher than negative 1 would be 0. 1 lower than negative 1 would be negative 2. 1 higher than 0, or 2 higher than negative 1 would be 1, and 2 lower than negative 1, or 1 lower than negative 2. I'm just creeping by 1 each of these x's. I get negative 3. Now, we're going to do the math out for each of these so that you can see the evidence. Okay, so let's start with this 1. So we're going to get y equals 3 times 1 plus 6 times 1 minus 4. And that gives me 3 plus 6 minus 4. That's 9. Take away 4 equals 5. Okay, so 5 goes here. Let's deal with 0. So we get y is equal to 3 times 0 plus 6 times 0 minus 4. So that gives me just minus 4. Okay, so let's do negative 2. And I have 3 times negative 2 squared. I forgot to write squareds here. And then plus 6 times negative 2 minus 4. And we're going to get negative 2 squared is 4. 4 times 3 is 12. 6, negative 6 times negative 6. Let's see. Oh, that's a plus there. I was going to say, wait a second, something didn't work out. There we go. And then we have minus 4, so those go out and we get negative 4. Oh, see what I said? All right, last one. So we're going to get y equals 3, and we have negative 3 squared plus 6 times negative 3 minus 4. That's going to give me negative 3 squared is 9. 9 times 3 is 27. And then we have negative 18 minus 4. So that's going to give me a positive 5. So notice what happens. These guys have matching y's. And these guys have matching y's. And that's what's going to happen when you pick your x's to be equidistant from your vertex x. One above, one below. 2 above, 2 below. Okay? Now, we're going to go ahead and graph this baby. So I'm going to add some graph paper. And let's see. So we need to go down to negative 7. And then we're going to go negative 3. So we'll just kind of do it like this. This one, we're going to have to go a little further, I think. Oh, that'd be good. Okay. And we didn't have anything. Okay, so we're going to, put my numbers in. So here's 2, here's negative 2, negative 2, negative 4, negative 6. And we're just going to go ahead and graph. This is your x, this is your y. All right, so vertex is at negative 1, negative 7. My matching little guys, we're at 0, negative 4. Oops, I need to go a little. 0, negative 4 is right here. And we're at negative 2, negative 4. Okay, and then we have 1, 5. Oops, I need to go up higher. Once you know it's at the top. So much for my good planning, right? Should have put it down a little further. All right, and then we'll go back to here, and then we're at 1, 5, which is right here, and then we're at negative 3, 5, which is right here. If it'll let me graph. Oh, it's being fussy. Won't let me graph. All right, well, we'll just sketch it. So I kind of sketch up this way. And we go right there. Okay? So what's the domain? all real numbers. What's the range? The y values such that y is greater than or equal to -7. Okay? Told you this was going to be a long set of notes. Okay, we're going to go ahead and do another one. And the directions say find the vertex. The equation. Of the axis of symmetry. And the y-intercept. Of the graph. Okay. So we're going to give you a graph. Make it look like this. So here's your x, here's your y. Have some important points that we're going to have. One at 2, 4. Or no, sorry. One at 2, 3. We'll have another point that's going to be at 0, -1. So we make a little mark here. And then we would have one at 4, -1, and then we'll just kind of sketch it in. Okay, so let's start with the vertex. We just grab this guy, and then he's at 2, 3. Axis of symmetry. Now, remember what it said. It said write the equation. I have too many people that don't write an equation and they just write a number. It's always going to start with x equals. Well, it's going to pass through that vertex, so it's got to be, x equals 2. And then what's the y-intercept? Where does it cross the y-axis? At 0, -1. Okay? All right, let's do a little bit more graphing, more equations, see if I can get this to stop. So, oh my goodness. I'm so sorry this is so long. But this is really important, and it's not an easy thing just to run through, okay? So we're going to graph. Oops, sorry. It's fussy. So we're going to graph the following equations. And your notes are only as good as you make them to be. So sloppy notes aren't going to help you in the long run. So we're going to do two different equations here. We have y equals x squared minus 4x plus 5. And we're going to have y equals negative x squared minus 2x plus 2. So I'm going to just do the left one, and then we'll do the right one. So we're going to start with identifying a, b, c. So remember, if you don't see a coefficient, it's going to be 1. We're going to find the axis of symmetry. And we're going to have x equals the negative of b over 2a and that's going to give me 4 over 2, which gives me x equals 2. That's going to be my x-coordinate for the vertex. So we're going to figure out the y-coordinate. So we get y equals 2 squared minus 4 times 2 plus 5. And that's going to give me 4 minus 8 plus 5 for a whopping 1. Oh my goodness, sorry, my cat is stealing my other cat's food. And so I put them together, and I get the vertex is going to be at 2, 1. I'm going to do my table of values. Vertex goes in the middle. 1 above is 3, 1 below is 1, 2 above is 4, 2 below is 0. Now, I'm going to be smart because I've picked my x's the right way. What I'm going to do is pick the easier x's to substitute into the equation and solve. So I'm going to go with the guys on the bottom. So I'm going to have y equals 1 squared minus 4 times 1 plus 5, which is going to give me 1 minus 4 plus 5, which is going to give me 2. So that goes here and here. And then y equals 0 squared minus 4 times 0 plus 5 gives me 5. Okay, and then I'm going to graph this. So I have only positives. I'm going to count just by 1 square at a time. X, Y. So we go 1, 2, 3, 4, 5. 2, 4, 6. And then 1, 2, 3, 4, 5, 6. So 2, 4, 6. I'm going to graph my 5 points, 0, 5, 3, 0, 5, 1, 2, 2, 1, 3, 2, and 4, 5. And then I just kind of sketch it in. And there we are. Let's try the second one. So again, identify A, B, and C. A is -1, B is -2, C is 2. I'm going to figure out the axis of symmetry. And I get x is equal to the negative of A, the negative of B over 2A, which equals 2 over -2, which gives me x equals -1. Okay, then I'm going to figure out the vertex. And I'm going to get y equals the negative of -1 squared minus 2 times -1 plus 2. That's going to give me the negative of 1 plus 2 plus 2, which gives me 3. So my vertex is -1, 3. I create my table. I'm going to put -1, 3 in the center. I'm going to go 1 above. -1 would be 0, 1 below would be -2, 2 above would be 1, 2 below would be -3. And then I'm going to go again with my easier numbers to calculate with. And we'll start with let's see. Yeah, we'll start with the first guy, then 1, and we're going to get y equals the negative of 1 squared minus 2 times 1 plus 2 gives me negative of 1 minus 2 plus 2, and that ends up giving me a negative 1. And that should be the same thing I get with negative 3, okay? And then I'm going to put in 0, so I get y equals the negative of 0 squared minus 2 times 0 plus 2, so the first 2 cancel out, and I get a 2, okay? Then I'm going to go ahead and graph this. So I'm going to actually use 2 boxes this time. See, nope, I want to do this the other way. Go down like this. So we're going to go 1, 2, 3, 4. And then we're going to go 1, 2, 1, 2, 1, 2. Okay, and then I'm just going to plot my 5 points. So I have 1, negative 1. I have 0, 2. Negative 1, 3. I have negative 2, 2. Oops, sorry, I did that wrong. I counted. Ay, ay, ay. This is when I need to be in class with you guys and you say, didn't you put the wrong number there? There we go. So we have negative 2, 2, and then we have negative 3, negative 1. And then again, we have a parabola. So you might ask yourselves, what do you think makes a parabola face upward, or what makes a parabola face downwards? And look at your 2 equations and see if you can see anything that can happen, okay? So on this guy, let's see. Let's do a little investigation on the left. So our vertex was a minimum, right? Because it's at the lowermost point. Okay? And what I notice is interesting is that the A value was positive. Okay? And that led to the parabola facing upward. Okay? And some people refer to that as a smile. Now, in the second one, our vertex was a maximum, right? Because it was at the topmost point. My A value this time, however, was less than 0 or negative. And the parabola is facing downward. So that pattern is always true. Okay, next screen. So sometimes we'll be asked questions and we don't need to actually graph it if we understand some properties about our parabolas. So, oops, let me go to black. Looking at an equation, we're going to determine if it has a minimum or maximum. So looking at its vertex, do you think it's going to be a minimum or a maximum? maximum. Okay, so that's the first thing. So remember what we just discovered. Is A positive or negative? Okay. Next, we're going to find the minimum or maximum. And the two things we're going to look for is the vertex and we're going to also look for the axis of symmetry. Okay. And then we're going to state the domain or range. And range. And if you remember, the domain will always be all real numbers, and the range is going to start with the y-coordinate of the vertex, and depending upon the way the parabola is facing, you're either going to have a greater than or equal to or a less than or equal to. Now, in this problem, you are not going to graph, okay? Do not graph. So you're just going to look at the equation and draw these conclusions. So, first equation, y is equal to negative 2x squared minus 4x minus 6, or plus 6, excuse me. So, we're going to identify our three key players. A is negative 2, B is negative 4, C is 6. And I know we haven't used C, but that's okay, that'll come later. Okay, so first, is it a minimum or maximum? So looking at A is equal to negative 2, we noticed on the last one that means our parabola is going to be facing downward. So that means our vertex is going to be a maximum. Okay, second, we're going to find that actual minimum or maximum, and we're going to do the axis of symmetry. So we go through that process. And we're going to get x is equal to negative b over 2a. So that gives me 4 over negative 4 or negative 1. Okay. Then I'm going to take that value of negative 1 and I'm going to substitute it back into the equation and solve for y. So I get negative 2 times negative 1 squared, and then minus 4 times negative 1, and then plus 6. Okay, and that's going to give me negative 2 times, let's see, negative 1 squared is 1, so I get negative 2. Negative 4 times negative 1 is positive 4 plus 6, and I get y equals 8. So my maximum is located at negative 1, 8. Domain and range. Okay, domain is simple. Domain is equal to all real numbers. Okay, what's the range? Okay, it's going to be all the y values. such that y, and because we have a maximum, that means we're pointing downward, so we're going to have less than or equal to, and we're going to grab that 8. Okay? And then we've got one more. This one wants us to figure out the y. I'm going to give you a second set of directions here. Slightly different. So we're going to find the vertex. The axis of symmetry. And the y-intercept. Okay, so our equation is the function at x is x squared plus 4x plus 3. So we're going to start with the vertex. And that means we have to do the axis of symmetry first. So we get the axis of symmetry is equal to negative b over 2a. So we have the negative of, a is 1, b is 4, c is 3. So we're going to have negative of 4 and 2 times 1. And we get negative 4 over 2, and that gives us x equals negative 2. Okay? And I should have written that over here as x equals negative 1. Bad me. All right, now that we have that, we can go ahead and figure out the vertex. And to do that, we're going to have to figure out what the y-coordinate is. Same as f of x, right? So I'm not going to worry about that. Well, I'll put it in this way. You haven't seen this written in a while. So we're going to take that negative 2. And everywhere I see x, I'm going to write negative 2. So negative 2 squared plus 4 times negative 2. And then plus 3. So that's going to give me 4 minus 8 plus 3, which is going to give me a grand total of negative 1. Okay, so then my vertex is equal to negative 2, negative 1. So that's the first one. Now, interestingly enough, I already figured out the axis of symmetry. To get that, now the y-intercept, the y-intercept is where the x equals 0, remember? So we substitute in 0 for x and we solve. So we get f at 0 is equal to 0 squared plus 4 times 0 plus 3, and we get f at 0 equals 3. So the y-intercept is 0, 3. And believe it or not, we are done. That was crazy long. Thank you for hanging in there, guys. We'll talk to you soon. Bye.